today we are going to see the topic about psychrometry. So psychrometry is basically it is a topic in thermodynamic. So we have seen so many thermodynamic process, so many thermodynamic cycles. So this is one among a type following the principle of thermodynamic processes, thermodynamic cycles. So it is having a different applications. So psychrometry. So psychrometry is basically the study of the different water vapor, the water mixtures, and the water vapor in the air. So it is the science of studying moisture and the dry air preferably in the atmosphere. So that is actually psychrometry. So we use psychrometry in basically in the air conditioning system, like our normal AC systems, AC ducts. So where the air conditioning, the air should be conditioned, the moisture also it should be conditioned. So we know where the properties of air is different, the property of water is different. So when we have moisture in the air, so it affects the humidity. So this is actually the study. So this study is actually called as psychrometry. So in a simple way, we can say psychrometry is the study of moisture and both moisture. When we say it is a mixture of the dry air and the amount of water vapor in the atmospheric air. So let us see, before going to the psychrometry, so we need to understand the various properties in the psychrometry. So this is actually a psychrometric chart where in the x-axis we have the temperature, that is our dry bulb temperature, and in the y-axis we have the humidity, that is the humidity ratio or the specific humidity. So the graph which shows the x-axis the temperature, the y-axis the humidity. So where my my moist air and my dry air, it basically differs when the temperature and the humidity changes. And we have so many curves here. So let us see the curve which is having the relative humidity. It shows the curve where the relative humidity changes. And we are having saturation line. So beyond that saturation line, my air will be forming, my dry air will be completely formed into dew, that is the water content. So that is where it is mentioned as dew point. And we are having an inclined line here. It is called as wet bulb temperature. Like we are in x-axis, we are having dry bulb temperature, and the inclined line inside the chart, it shows the wet bulb temperature. So we know the dry bulb temperature and wet bulb temperature are measured by the psychrometer. The psychrometer is the temperature measuring instrument which measures the dry bulb temperature and wet bulb temperature. And of course, the volume. So we need to have the density of the air. So here the inclined line, the larger inclined line shows the specific volume content. So this chart shows the relation between all the properties in the psychrometry, the psychrometric process. And next we go for, we need to know what are the process involved in the psychrometric system. So like when we take an air conditioning system, there are many thermodynamic processes going on. So this is the psychrometric process. So what are the basic psychrometric process? Sensible heating, sensible cooling, humidifying, dehumidifying. So these are the four major psychrometric processes in any psychrometric system, preferably an air conditioning system. And of course, for our convenience, to condition the air. So basically, psychrometry is to have a conditioned air for human comfort and for other comfort. So basically, to improvise the conditioning, people will go for a few other processes like adiabatic cooling process, adiabatic mixing process. So these are the major psychrometric process involved. So this can be represented in the psychrometric chart. So when we see this psychrometric chart, we can see the right side arrow mark, it represents sensible heating. The horizontal arrow mark which goes to the right side, it represents sensible heating. and the left side horizontal arrow mark, it represents sensible cooling. Similarly, when we see the vertical arrow mark which is going upward direction, it is humidifying. The vertical arrow mark going downward direction, it is dehumidifying. So when we add moisture, it is humidifying. When we remove moisture, it is dehumidifying. So that is about the humidification process. When we add moisture to the atmosphere, naturally the water content will increase, so the humidifying will takes place. When we remove moisture from the atmosphere, the percentage of water vapor, it reduces, so it goes for dehumidifying process. So that is represented from this, easily identified from this psychrometric chart. Like when we take for an example, the inclined line in the right side, it shows heating and humidifying. So normally in a system, for example in an air conditioning system, if it is an year-round air conditioning, we require heating, we require cooling. So here we can have various combinations. We can have humidifying, heating and humidifying. We can have heating and dehumidifying, and the other way around. We can have cooling and humidifying, and we can have cooling and dehumidifying. So what are these four major processes? Let us see one by one. So the first thing, sensible heating. When you take an air conditioning system, we require heating and cooling also. So sensible heating, you can see in this simple line diagram. So this is where a coil. So when it is heating, we require a heating coil. So the heating coil, it gives some heat addition to the system. So the inlet, the suffix 1, it represents inlet condition. So mass M1, temperature at inlet T1, enthalpy at inlet H1, and mass at exit, temperature T2 is exit temperature, H2 is exit enthalpy. So when we supply, when the inlet air is heated, it is called as heating. So when we heat this moisture without adding water vapor to the system, it is called as sensible heating. So when we are heating, we are not adding any moisture to the system, it is called as sensible heating. So during this sensible heating, the condition of humidity, what is the condition of specific humidity? The specific humidity remains constant. So that can be easily seen here. So when we are adding heat, so the dry bulb temperature increases. So T1 is the inlet dry bulb temperature, T2 is the exit dry bulb temperature. So when sensible heat takes place, so temperature increases from T1 to T2, maintaining the specific humidity constant, that is omega 1 equal to omega 2. So this is actually sensible heating, so which can be thermodynamically calculated. This is Q is equal to mass into Cp into del T. So this is sensible heating process. So the other way, so we need to have cooling also. In an air conditioning system, we need to cool the system. The same process, instead of having a heating coil, here we are having a cooling coil. So this cooling coil will remove heat from the moisture without removal of any moisture from the system. So this is called as sensible cooling process. This again can be shown from this diagram. When we are adding heat, when we are removing heat from the system, the dry bulb temperature changes, it decreases. So left side arrow mark, it shows cooling, sensible cooling. The dry bulb temperature decreases at constant specific humidity. So without removing the moisture, we have to have a cooling process. This is called as sensible cooling process. So like we said, we can have different combinations, the cooling and dehumidification process, that is the removal of heat is taking place and the moisture. So this is called as the combination. This combination here, it is called as cooling and dehumidifying. So dehumidifying is actually what? Dehumidifying is we are removing moisture from the atmosphere and moisture from the water vapor. So we are removing moisture content. When we remove moisture content at constant temperature, so during humidification or dehumidification process, our dry bulb temperature remains constant. So the water vapor content, it reduces. So during dehumidification process, the specific humidity decreases, which can be seen from this chart. So this actually shows the representation where the dehumidifying taking place. And the other combination, like we can have heating and dehumidifying, like we have seen in the previous slides, we can have different combination of psychrometric process. So this shows heating and humidifying process. So heating means sensible heating, that is we are adding heat to the system, and humidifying means we are adding moisture to the moisture. So when we add moisture, the humidifying takes place, which is the the specific humidity increases. So this involves sensible and latent heat transfer. So the combination of heating and humidifying. And what is humidifying? We know adding moisture to the system. So here the system is my moisture in the air conditioning system. So when we add moisture, the water vapor in that system, it increases. So naturally the humidity, specific humidity, it also increases. So this schematic represents when humidifying, we are actually adding moisture to the system during constant dry bulb temperature process. So during humidifying and dehumidifying process, my dry bulb temperature remains constant. So which is where the humidifying takes place. So likewise, we can have different combinations, which is the previous slides. Yes, we have seen. We have different combinations in the psychrometric chart. So sensible heating, sensible cooling, humidifying and dehumidifying. So we can have a different psychrometric process. So accordingly, we can design our air conditioning system for the comfort. Basically, psychrometric process is for having a comfort conditions. So by using all this thermodynamic, all this psychrometric process, we can have a comfort air conditioning system. So this is about the basics and the various psychrometric process involved in the psychrometric system. Thank you. Zoom பண்ணிட்டேன்.